Well, hi there and welcome. My name is Rebecca Weaver. We're looking at section 7.6 today on double integrals in our applied calculus class. So what's the double integral of f of xy over a region R? For a given function f of xy in a region R in the xy plane, the volume of a solid above the region given by the graph of xy minus the volume of the solid below the region given by the graph of xy. Let R be the region in the xy plane bounded by the graphs of y equals g of x and y equals h of x, and the vertical lines x equals a and x equal b. Then the double integral of f of xy dxy is equal to the integral from a to b along with the integral from g of x to h of x of f of xy with respect to y and then respect to x. Oh my, let's just do one. So here what we're going to do, go inside first. We're going to calculate the iterated integral. We're going to go deep inside. We need to calculate first the integral of x to 2x of y dy. So just calculating that inside is what we're going to get first. Here g of x is x and h of x is 2x. We're going to evaluate the integral first. The variable in this integral is y because of the dy. So that's just going to be our y squared over 2 evaluated from x to 2x. So just taking that inner integral, we're going to get that that is our x squared over 2, and then we're going to plug in our x and our 2x and do that subtraction just as we do with our definite integrals. We'll get that that's 3 over 2x squared. Now we plug that into our integral so we can take the integral with respect to x. So plugging that in from 0 to 3 of 3 halves x squared dx. So we find that integral is 1/2 x cubed. We're going to evaluate that from 0 to 3, and we'll get that that's 27 over 2. All right, so the value of the iterated integral is 27 over 2. Let's do another one. We need to calculate the volume over the region R bounded by the graph of f of xy is x squared y squared. Now R is the rectangle bounded by the lines x equal 1, x equal 3, y equals 0, and y equal 1. So the desired volume is given by the double integral over that region of x squared plus y squared. Take those integrals with respect to x and then y. By the result just cited, this double integral is equal to the following iterated integral. So look at your limits of integration on the outside, since we are having our dy at the very end there. We put our limits of integration with respect to y first from 0 to 1, and you see that those relate to the dy. The 1 and the 3 relate to x, and that would be what you would put on the inside when you take your integral with respect to x. So we're going to take those integrals first, treating that y squared as just a constant first because we're doing the integral with respect to x first. So here we go. We're going to take that integral with respect to x. Notice we treated the x as a constant, so we just had x cubed over 3 plus xy squared evaluating from 1 to 3. We're going to get, and plugging that in, we're going to get that that is 26 over 3 plus 2y squared. Now we're going to carry out the integration with respect to y. So we plug that into our integral, and we'll have the integral from 0 to 1 of 26 over 3 plus 2y squared. That's what we just calculated. We're taking that with respect to y. So we integrate that with respect to y. We'll get 26 over 3y plus 2/3 y cubed. Then we evaluate that from 0 to 1, plugging those values in, doing our subtraction. We'll get that that's 28 over 3. So the value of the iterated integral is 28 over 3. Notice we could have set it up the other way too, and it would have given us the same answer. All right, and that's all we have for this section. So if you have any questions, be sure and email me. My email is rweaver10@alaska.edu. Have a fantastic day.